Hello there, welcome to the October 2020 applied paper. Here we're looking at the second mechanics question, question 7 overall in the paper. A particle P moves with acceleration of 4I minus 5j meters per second squared. At time t equals 0, P is moving with velocity minus 2I plus 2j meters per second. Find the velocity of P at time t equals 2. So we've got it basically a v equals u plus at equation, isn't it? So we want to work out the final velocity, we've got the initial velocity, we've got the acceleration, we've got the time, so let's just work it out. So it's going to be, the initial speed is minus 2 plus 2 for the time, times the acceleration, which is 4 minus 5, and that's going to be minus 2, add 8, so that'll be 6, and then it's going to be minus 8 down there. So it's going to be 6I minus 8j, brackets, meters per second. There we are, that's the answer for part A. At time t equals t, where t is greater than 0, the particle P passes through a point A. The position vector of A is lambda I minus 4.5j relative to O, where lambda is a constant. Find the value of t. Well, in this case here, we want to use a different Suvat formula, S equals ut plus half at squared. So we don't know this position vector is going to be lambda minus, yes, we know S is going to be lambda minus 4.5 relative to O, and it will pass through O at time t equals 0. Yeah, so we don't have any initial position, it's just 0. So it's going to be lambda minus 4.5 equals u, which is the initial velocity, times the time, so it's going to be t times by minus 2, add a half t squared of the acceleration, which is going to be 4 minus 5. Okay, so what I think I'll do here is I'll make an equation out of the j component, or the y variable. So that's going to be minus 4.5 equals 2t minus 5 over 2 t squared. So let's move all of that onto one side. 5 over 2 t squared minus 2t minus 4.5 equals 0. And I'm sure we'll get two values for t. Let's just type that into the polynomial solver in the calculator. So scroll down, equation, polynomial mode, degree 2, 2.5 minus 2 minus 4.5. And we're going to get 9 over 5, so 1.8, or a negative 1. We don't want the negative 1. We just want t equals 1.8. Okay, so there we are. That's the answer for part B. Let's now move on to part C. So for part C, it says find the value of lambda. That's the kind of the I component of the position vector. So we'll use the top row of that equation down below there. So lambda equals minus 2 times t, so 1.8 times minus 2, add a half times 1.8 squared times 4. Okay, and let's type that all into the calculator. So 1.8 times minus 2, add 0.5 times 1.8 squared times 4, and that will give us an answer of 2.88. So lambda equals 2.88 is the answer for part C. So there we are, that's our answer for question 2 in total there, worth a total of 8 marks. Let's now move on to the third mechanics question.